Introduction to P&ID, Understanding Process and Instrumentation Diagrams. This video serves as an introduction to Process and Instrumentation Diagrams, P&ID, and aims to provide viewers with a foundational understanding of what P&ID is and why it is important in various industries. The video would start by defining P&ID as a graphical representation of a process system that illustrates the interconnections between equipment, instruments, piping, and control systems. It would emphasize that P&ID is a crucial tool used in process design, operation, and maintenance. Next, the video would explain the key elements and information conveyed by a P&ID. It would touch upon the symbols used to represent equipment, such as pumps, valves, heat exchangers, and vessels, as well as instruments like pressure gauges, flow meters, and temperature sensors. The video would highlight that P&ID provides a visual representation of how these components are interconnected and how materials and information flow within a process system. Furthermore, the video would discuss the importance of P&ID and process safety. It would explain how P&ID aids in identifying potential hazards, understanding process flows, and implementing safety measures. The video would emphasize that accurate and up-to-date P&ID documentation is essential for effective communication among stakeholders and ensuring the safe and efficient operation of process systems. Lastly, the video would conclude by summarizing the key takeaways and highlighting the relevance of P&ID across a range of industries, including oil and gas, chemical, pharmaceutical, and manufacturing. Overall, this video serves as a comprehensive introduction to P&ID, aiming to provide viewers with a solid understanding of its purpose, components, and significance in process engineering and industry operations. Key components of P&ID, symbols and notations explained. In this video, the focus is on delving deeper into the various symbols and notations used in Process and Instrumentation Diagrams, P&ID. The goal is to provide viewers with a comprehensive understanding of these graphical elements and their significance in conveying information within a P&ID. The video would start by introducing the concept of symbols and notations in P&ID. It would explain that these graphical representations are standardized and universally recognized, allowing for clear communication and understanding across different industries and disciplines. Next, the video would delve into the most commonly used symbols in P&ID, such as valves, pumps, instruments, pipes, tanks, and heat exchangers. It would explain the graphical representation of each symbol, including their shape, size, and distinctive features. The video would also highlight the importance of consistency and symbol usage within a P&ID to avoid confusion. Furthermore, the video would discuss the significance of line types and notations in P&ID. It would explain how different line types, such as solid lines, dashed lines, and dotted lines, convey different meanings, such as the flow of materials, the direction of flow, and the presence of control systems. The video would also cover notations for specific parameters, such as temperature, pressure, and flow rate, and how they are represented in P&ID. To enhance understanding, the video would provide real-world examples and walk viewers through the interpretation of P&ID symbols in practical scenarios. It would demonstrate how symbols and notations come together to represent the entire process system and its various components. Finally, the video would conclude by summarizing the key symbols, line types, and notations covered in the video. It would emphasize the importance of becoming familiar with these graphical elements to effectively read and interpret P&ID diagrams. Overall, this video aims to provide viewers with a comprehensive understanding of the symbols and notations used in P&ID. By explaining the purpose and significance of each graphical element, the video equips viewers with the knowledge to navigate and interpret P&ID diagrams accurately and effectively. Interpreting P&ID, how to read and analyze process and instrumentation diagrams. This video focuses on providing a step-by-step guide on how to read and analyze process and instrumentation diagrams, P&ID. It aims to equip viewers with the skills and techniques necessary to navigate and extract valuable information from P&ID diagrams. The video would start by introducing the importance of accurate interpretation of P&ID. It would emphasize that a thorough understanding of P&ID is essential for tasks such as troubleshooting, process optimization, and ensuring operational efficiency and safety. Next, the video would discuss the systematic approach to reading and analyzing P&ID. It would outline the following key steps. 1. Familiarizing with the P&ID layout. The video would explain the layout of a typical P&ID, highlighting the key sections such as the equipment area, piping section, and instrument legends. 1. It would emphasize the importance of understanding the overall structure to navigate the diagram effectively. 2. Identifying equipment and instrumentation. The video would explain how to recognize and interpret the symbols used to represent different equipment and instruments within the P&ID. 2. It would discuss the importance of understanding the function and operation of each component to grasp the overall process flow. 3. Tracing process flow. The video would guide viewers on how to trace the flow of materials and information through the piping and instrumentation in the diagram. 3. It would explain how arrows, line types, and notations indicate the direction and nature of the flow, such as liquid, gas, or control signals. 4. Analyzing process parameters. The video would highlight the importance of identifying and interpreting process parameters, such as temperature, pressure, and flow rate, indicated on the P&ID. 4. It would explain how these parameters influence the operation and control of the process system. 5. Understanding control systems. The video would cover the representation of control systems and loops within the P&ID. 5. It would explain how control valves, sensors, and actuators are depicted and their role in regulating process variables. Throughout the video, practical examples and illustrations would be used to demonstrate the interpretation process and provide real-world context. Finally, the video would conclude by summarizing the key steps and providing tips for effective interpretation of P&ID. It would emphasize the importance of practice and continuous learning to improve proficiency in reading and analyzing P&ID diagrams. Overall, this video aims to empower viewers with the skills and techniques needed to read and analyze P&ID effectively. By following a systematic approach and understanding the key components, viewers can extract valuable insights and make informed decisions related to process systems. P&ID Design Guidelines. Best practices for creating effective diagrams. This video focuses on providing viewers with best practices and guidelines for creating clear, concise, and effective process and instrumentation diagrams, P&ID. It aims to help viewers understand the principles and considerations involved in designing P&ID diagrams that are easy to understand, navigate, and use. The video would begin by emphasizing the importance of thoughtful P&ID design. It would explain that well-designed P&ID diagrams are essential for effective communication, collaboration, and troubleshooting in process industries. Next, the video would discuss the following key design guidelines and best practices for creating P&ID diagrams. 1. Logical layout organization. The video would emphasize the significance of organizing the P&ID in a logical and intuitive manner. 1. It would discuss the importance of arranging equipment, instruments, and piping in a way that reflects the actual process flow and promotes easy comprehension. 2. Consistent symbol usage. The video would highlight the importance of using standardized symbols consistently throughout the P&ID. 2. It would explain how consistent symbol usage ensures clarity and avoids confusion for anyone reading the diagram. 3. Clear and concise labeling. The video would discuss the importance of clear and concise labeling for equipment, instruments, and piping components. 3. It would explain the significance of using descriptive labels and avoiding ambiguous or overloaded information. 4. Color coding. The video would explore the use of color coding in P&ID design. 4. It would explain how color can be utilized to enhance visual understanding, differentiate process streams, highlight critical components, or indicate safety-related information. 4. It would emphasize the importance of using color consistently and meaningfully. 5. Line types and thickness. The video would discuss the significance of line types and thickness in P&ID design. 5. It would explain how different line types, such as solid lines, dashed lines, or dotted lines, can represent different types of connections or flows. 5. It would also highlight the importance of using appropriate line thickness to differentiate between major and minor lines. 6. Annotation conventions. The video would cover the use of annotations and notes in P&ID design. 6. It would explain how annotations can provide additional information or clarify specific details. 6. The video would discuss the importance of following consistent annotation conventions, such as using arrows, callouts, or numbering systems. 7. Revision control and versioning. The video would address the importance of revision control and versioning in P&ID design. 7. It would explain the significance of maintaining an accurate history of revisions and version updates for effective change management and documentation. Throughout the video, practical examples and visual demonstrations would be used to illustrate the design guidelines and best practices. Finally, the video would conclude by summarizing the key design principles and guidelines discussed. It would emphasize the importance of considering the audience, purpose, and context while designing P&ID diagrams. Overall, this video aims to provide viewers with practical guidance on designing effective P&ID diagrams. By following these best practices, viewers can create P&ID diagrams that are intuitive, informative, and easy to work with, leading to enhanced collaboration, communication, and overall process efficiency.
P&ID software tools, a comprehensive guide to choosing the right solution. This video focuses on providing viewers with a comprehensive guide to choosing the right software tool for creating and working with Process and Instrumentation Diagrams, P&ID. It aims to help viewers understand the features, capabilities, and considerations when selecting P&ID software solutions that align with their specific needs and requirements. The video would start by discussing the importance of P&ID software tools in modern process industries. It would highlight how these tools streamline the design, documentation, collaboration, and maintenance processes associated with P&ID diagrams. Next, the video would cover the following key aspects to consider when choosing P&ID software tools. 1. Functionality and features. The video would explore the core functionality required in P&ID software tools, such as drag-and-drop symbol libraries, intelligent line routing, automatic numbering, database integration, and 3D visualization. 1. It would discuss the importance of assessing the specific features and capabilities needed based on the complexity and scale of the projects. 2. User interface and ease of use. The video would emphasize the significance of user-friendly interfaces and intuitive workflows in P&ID software tools. 2. It would explain the importance of selecting tools that have a logical and easy-to-navigate interface, as well as customizable settings to suit individual preferences. 3. Compatibility and integration. The video would discuss the importance of compatibility and integration capabilities with other software tools and systems. 3. It would highlight the benefits of selecting P&ID software that can seamlessly exchange data with other design, engineering, or project management software to ensure smooth collaboration and data consistency. 4. Collaboration and documentation. The video would address the collaboration and documentation features of P&ID software tools. 4. It would explore functionalities such as real-time collaboration, cloud-based storage, revision control, and automated documentation generation. 4. The video would emphasize the importance of these features for efficient team collaboration and accurate documentation. 5. Support and training. The video would discuss the availability of support resources and training programs provided by the software vendors. 5. It would highlight the importance of selecting tools that offer comprehensive technical support, user manuals, online forums, and training options to ensure smooth implementation and usage. Additionally, the video would touch upon other factors to consider, such as cost, licensing models, vendor reputation, and future scalability of the software. Throughout the video, the use of visual demonstrations, screenshots, and comparisons between different software tools would help viewers understand the concepts better. Finally, the video would conclude by summarizing the key considerations and offering guidance on making an informed decision while choosing P&ID software tools. Overall, this video aims to provide viewers with a comprehensive understanding of the factors to consider when selecting P&ID software tools. By considering these aspects, viewers can choose the right software solution that best suits their needs, leading to enhanced productivity, accuracy, and efficiency in P&ID design and management. P&ID validation and verification, ensuring accuracy and reliability. This video focuses on the importance of P&ID validation and verification processes in ensuring the accuracy, reliability, and integrity of process and instrumentation diagrams, P&ID. It aims to provide viewers with an understanding of the methodologies and best practices for validating and verifying P&ID diagrams. The video would start by explaining the significance of P&ID validation and verification. It would emphasize that these processes are essential for identifying errors, inconsistencies, and discrepancies in P&ID diagrams, which could lead to operational inefficiencies, safety risks, and costly mistakes. Next, the video would cover the following key aspects of P&ID validation and verification. 1. Reviewing engineering design data. The video would discuss the importance of reviewing the engineering design data against the P&ID, including process flow diagrams, equipment specifications, and instrument datasheets. 1. It would explain how this review helps identify any discrepancies or omissions in the P&ID. 2. Consistency checks. The video would explain the process of conducting consistency checks on the P&ID. 2. It would cover aspects such as verifying the correct usage of symbols, ensuring proper line connections, and confirming the alignment of equipment and instrumentation with the actual process design. 3. Compliance with standards and regulations. The video would emphasize the importance of validating the P&ID against relevant standards, regulations, and industry guidelines. 3. It would explain how compliance checks help ensure that the P&ID adheres to safety, environmental, and operational requirements. 4. Cross-discipline collaboration. The video would highlight the significance of cross-discipline collaboration in P&ID validation and verification. 4. It would explain how involving stakeholders from different engineering disciplines, such as process, mechanical, electrical, and instrumentation, helps in identifying potential issues and ensuring overall consistency. 5. Software-based validation tools. The video would discuss the use of software tools specifically designed for P&ID validation and verification. 5. It would explore how these tools can automate checks, detect errors, and provide reports on inconsistencies or non-compliance, saving time and improving accuracy. 6. Documenting revisions and change control. The video would cover the importance of maintaining proper documentation and change control procedures during the validation and verification process. 6. It would explain how tracking revisions, documenting changes, and maintaining an auditable trail ensures the accuracy and integrity of the P&ID over time. Throughout the video, practical examples and visual representations would be used to illustrate the validation and verification processes. Finally, the video would conclude by summarizing the key steps and best practices for P&ID validation and verification. It would emphasize the importance of conducting these processes iteratively throughout the design and operational lifecycle of the process system. Overall, this video aims to provide viewers with a comprehensive understanding of the methodologies and best practices for P&ID validation and verification. By implementing these processes, viewers can ensure the accuracy, reliability, and compliance of P&ID diagrams, leading to improved operational efficiency, safety, and regulatory compliance. P&ID documentation, essential elements and effective practices. This video focuses on the essential elements and effective practices for documenting process and instrumentation diagrams, P&ID. It aims to provide viewers with a comprehensive understanding of the key components that should be included in P&ID documentation and the best practices for creating clear and comprehensive P&ID documentation. The video would start by emphasizing the importance of P&ID documentation. It would explain that well-documented P&IDs are crucial for effective communication, maintenance, troubleshooting, and regulatory compliance in process industries. Next, the video would cover the following key elements of P&ID documentation. 1. Equipment and instrumentation. The video would explain the importance of accurately documenting the equipment and instrumentation depicted in the P&ID. 1. It would discuss the details that should be included for each component, such as equipment tag numbers, instrument tag numbers, process parameters, and specifications. 2. Piping and connections. The video would highlight the significance of documenting the piping and connections within the P&ID. 2. It would explain the importance of including pipe sizes, pipe lengths, line numbers, valve types, and connection points to provide a clear understanding of the physical flow and layout of the process system. 3. Control systems and loops. The video would discuss the documentation of control systems and loops within the P&ID. 3. It would explain the importance of including details about control valves, sensors, actuators, interlocks, and control logic to provide a comprehensive understanding of the process control and automation aspects. 4. Line types and notations. The video would cover the documentation of line types and notations in the P&ID. 4. It would explain the importance of including details about line types, solid lines, dashed lines, etc., and notations, arrows, annotations, symbols, to convey information about flow directions, process parameters, and control systems. 5. Legends and abbreviations. The video would address the inclusion of legends and abbreviations in the P&ID documentation. 5. It would explain how using standardized legends and abbreviations helps to ensure clarity and consistency across different P&IDs and avoids confusion. Additionally, the video would discuss effective practices for creating P&ID documentation. 1. Consistency and standardization. The video would emphasize the importance of maintaining consistency and standardization in P&ID documentation. 1. It would explain how following consistent formatting, labeling, and annotation conventions enhances clarity and ease of understanding. 2. Clear and concise language. The video would discuss the importance of using clear and concise language in P&ID documentation. 2. It would emphasize the need to avoid ambiguous or complex wording and to ensure that the documentation is easily understandable by various stakeholders. 3. Revision control and versioning. The video would cover the importance of implementing revision control and versioning practices for P&ID documentation. 3. It would explain how tracking revisions, maintaining an audit trail, and clearly documenting changes are crucial for effective change management and compliance. Throughout the video, practical examples and visual representations would be used to illustrate the elements and best practices of P&ID documentation. Finally, the video would conclude by summarizing the key elements and effective practices discussed. It would emphasize the importance of creating clear, comprehensive, and well-documented P&IDs for efficient communication, maintenance, and compliance. Overall, this video aims to provide viewers with a comprehensive understanding of the essential elements and effective practices for P&ID documentation. By following these guidelines, viewers can create P&ID documentation that is clear, accurate, and reliable, facilitating effective communication and ensuring operational efficiency in process industries. P&ID change management, strategies for handling revisions and updates. This video focuses on providing viewers with strategies and best practices for effectively managing changes, revisions, and updates to Process and Instrumentation Diagrams, P&ID. It aims to help viewers understand the importance of change management in maintaining the accuracy, consistency, and integrity of P&IDs throughout the lifecycle of a process system. The video would start by highlighting the dynamic nature of process industries and the need for P&IDs to evolve and adapt to changes over time. It would emphasize that proper change management processes are crucial for ensuring that P&IDs accurately reflect the as-built state of the process system. Next, the video would cover the following key strategies and best practices for P&ID change management. 1. Change request and authorization. The video would explain the importance of establishing a formal change request and authorization process for P&IDs. It would discuss the need to have a structured workflow for initiating, reviewing, approving, and implementing changes to P&IDs. 2. Impact assessment. The video would emphasize the significance of conducting a thorough impact assessment before implementing any changes to the P&IDs. It would explain how changes can have ripple effects on various aspects of the process system, such as equipment, instrumentation, piping, and control systems. The video would discuss the importance of considering the implications on safety, compliance, and operational performance during the impact assessment. 3. Document control and versioning. The video would discuss the importance of maintaining proper document control and versioning practices for P&IDs. It would emphasize the need to track revisions, maintain an auditable trail, and clearly document changes made to the P&IDs. The video would explore the use of document management systems or revision control software to facilitate efficient change tracking and version control. 4. Cross-discipline collaboration. The video would highlight the significance of cross-discipline collaboration during the change management process. It would discuss the importance of involving stakeholders from various engineering disciplines, such as process, mechanical, electrical, and instrumentation, to ensure that all aspects of the P&IDs are considered and validated. 5. Communication and training. The video would address the importance of effective communication and training during P&ID change management. It would discuss the need to communicate changes to relevant stakeholders and provide proper training to ensure that all personnel are aware of the updated P&IDs and understand their implications. 6. Validation and verification. The video would emphasize the importance of validating and verifying the changes made to the P&IDs. It would discuss the need for thorough review and checks to ensure that the revised P&IDs are accurate, consistent, and compliant with standards and regulations. Throughout the video, practical examples and case studies would be used to illustrate the change management strategies and best practices. Finally, the video would conclude by summarizing the key strategies and best practices discussed. It would emphasize the importance of implementing a structured change management process for P&IDs to ensure accuracy, consistency, and compliance throughout the lifecycle of the process system. Overall, this video aims to provide viewers with a comprehensive understanding of the strategies and best practices for P&ID change management. By following these guidelines, viewers can effectively handle revisions and updates to P&IDs, maintaining their accuracy and integrity and facilitating seamless operation and maintenance of process systems. P&ID symbols and notations, understanding and interpreting common symbols. This video focuses on explaining the commonly used symbols and notations in Process and Instrumentation Diagrams, P&ID. It aims to provide viewers with a comprehensive understanding of these symbols and how to interpret them correctly to gain insights into the process system. The video would start by emphasizing the importance of symbols and notations in P&IDs. It would explain that these graphical representations convey crucial information about equipment, instrumentation, piping, and process flow, enabling engineers, operators, and maintenance personnel to understand and communicate the design and operation of the process system. Next, the video would cover the following key aspects of P&ID symbols and notations. 1. Equipment symbols. The video would discuss the commonly used symbols for various types of equipment in P&IDs. It would explain the symbols for vessels, pumps, compressors, heat exchangers, reactors, distillation columns, and other process equipment. The video would provide a detailed explanation of each symbol and its significance in representing the respective equipment. 2. Instrument symbols. The video would focus on the symbols used to represent instruments and control devices in P&IDs. It would cover symbols for flow meters, pressure gauges, level indicators, temperature sensors, control valves, actuators, and other instruments. The video would explain the purpose and functionality of each symbol and how it relates to the measurement and control of process parameters. 3. Piping symbols. The video would discuss the symbols used for piping and pipeline components in P&IDs. It would cover symbols for pipes, valves, fittings, flanges, reducers, and other piping components. The video would explain how these symbols depict the physical layout, connection points, and flow direction of the piping system. 4. Flow arrows and annotations. The video would explain the use of flow arrows and annotations in P&IDs. It would discuss how flow arrows indicate the direction of process flow within the system. The video would also cover the importance of annotations for providing additional information about flow rates, process conditions, and control systems. 5. Legends and abbreviations. The video would address the use of legends and abbreviations in P&IDs. It would explain how legends provide a key to interpreting symbols and notations, ensuring consistent understanding across different P&IDs. The video would also cover commonly used abbreviations and their meanings in P&IDs. Throughout the video, visual representations and examples would be used to illustrate the symbols and notations in P&IDs, making it easier for viewers to understand and interpret them correctly. Finally, the video would conclude by summarizing the key symbols and notations discussed. It would emphasize the importance of understanding these symbols to effectively analyze and communicate information about the process system represented by the P&IDs. Overall, this video aims to provide viewers with a comprehensive understanding of the symbols and notations commonly used in P&IDs. By gaining knowledge about these symbols, viewers can accurately interpret P&IDs and effectively communicate and collaborate with others involved in the design, operation, and maintenance of process systems. P&ID review and approval, ensuring quality and compliance. This video focuses on the importance of P&ID review and approval processes in ensuring the quality and compliance of Process and Instrumentation Diagrams, P&ID. It aims to provide viewers with an understanding of the significance of these processes and the best practices for conducting effective reviews and obtaining approvals for P&IDs. The video would start by highlighting the critical role of P&ID review and approval in the design, construction, and operation of process systems. It would emphasize that these processes help identify errors, inconsistencies, and compliance issues in P&IDs before they are implemented, ensuring safe and efficient operations. Next, the video would cover the following key aspects of P&ID review and approval. 1. Review objectives. The video would explain the objectives of the P&ID review process. It would discuss how the review aims to identify errors, ensure compliance with standards and regulations, verify consistency with the process design, and assess the operability and maintainability of the system. 2. Review participants. The video would discuss the importance of involving various stakeholders in the review process. It would explain the roles of different engineering disciplines, process operators, safety personnel, and regulatory authorities in providing their expertise and ensuring comprehensive review coverage. 3. Review criteria. The video would outline the criteria against which the P&IDs are reviewed. It would cover aspects such as accuracy, completeness, compliance with standards and regulations, clarity of symbols and notations, consistency with other design documents, and adherence to safety and operational requirements. 4. Review process. The video would discuss the best practices for conducting a thorough P&ID review. It would explain the need for a structured and systematic approach, including reviewing each section of the P&ID, conducting cross-discipline checks, verifying against design data, and using standardized review checklists or software tools. 5. Issue resolution. The video would address the process of resolving issues and discrepancies identified during the review. It would emphasize the importance of clear communication, collaboration, and documentation to ensure that all issues are addressed, resolved, and properly documented before obtaining approvals. 6. Approval process. The video would explain the procedures for obtaining approvals for the reviewed P&IDs. It would discuss the roles of designated approvers, the importance of sign-offs, and the need to maintain a proper record of approvals for reference and compliance purposes. Throughout the video, practical examples and visual representations would be used to illustrate the P&ID review and approval processes. Finally, the video would conclude by summarizing the key steps and best practices discussed. It would emphasize the importance of conducting thorough reviews and obtaining approvals to ensure the quality, compliance, and operational efficiency of P&IDs in process systems. Overall, this video aims to provide viewers with a comprehensive understanding of the significance of P&ID review and approval processes. By following these best practices, viewers can conduct effective reviews, address any issues or discrepancies, and obtain approvals that ensure the accuracy, compliance, and quality of P&IDs in their respective process systems.